March 25th, 2026, 0347 UTC. 12 hours ago, NASA's Space Surveillance Network logged a proximity telemetry return from the International Space Station's automated collision avoidance queue that the flight dynamics officer on the overnight shift at Johnson Space Center's Mission Control Flight Room 1 spent 4 minutes attempting to reclassify as a sensor calibration artifact before forwarding it without standard protocol documentation to the flight director's direct line. Because what the queue had returned was not a proximity figure. It was a formation figure, the kind of number that does not appear in a collision avoidance system. Because collision avoidance systems are not designed to process the possibility of an interplanetary object matching a crewed orbital station's velocity to within a fraction of a meter per second and holding that match for 4 consecutive hours across 2 complete orbits of Earth. At 0415 UTC on March 25th, 2026, 3IATLAS locked itself into a trailing position exactly 72.4 kilometers behind the International Space Station. Matched the station's orbital velocity of 7.66 kilometers per second to instrument measurement precision and maintained that distance and velocity without deviation for 4 hours, while 3 independent ground-based radar networks, NASA's Goldstone Complex, ESA's Space Debris Tracking Network, and the United States Space Surveillance Network, confirmed the formation geometry from separate hemispheres of Earth using separate methodologies and returned identical conclusions. The object did not pass the station. It did not execute a gravitational flyby arc that briefly approximated the station's orbital path. It followed the station. Exactly. And whatever physical mechanism produced that behavior has no entry in 4 centuries of documented cometary science. No analog in the complete catalog of near-Earth object encounters, and no natural explanation that survives contact with the orbital mechanics the data requires. To understand why the co-orbital resonance lock alone, before the magnetic field measurement, before the surface temperature contradiction, before the prime number sequence returned at 0814 UTC, constitutes a categorical impossibility under every passive orbital dynamics framework available to planetary science, the physical requirements of what 3IATLAS executed must be stated in precise quantitative terms against what any naturally behaving body arriving from interplanetary space can produce. The International Space Station maintains a mean orbital altitude of approximately 408 kilometers above Earth's surface, within the thermospheric layer, where residual atmospheric constituents at densities between 10 to the negative 9th and 10 to the negative 11th kilograms per cubic meter exert continuous aerodynamic drag on the station's orbital energy, requiring periodic reboost maneuvers to maintain altitude against decay. At 408 kilometers, the circular orbital velocity demanded by Earth's gravitational parameter is 7.66 kilometers per second, a value fixed by Keplerian orbital mechanics with no flexibility for any object at that altitude, regardless of its origin, composition, or mass. An object arriving from interplanetary space at the heliocentric velocity documented for 3IATLAS carries an Earth relative hyperbolic approach velocity at low Earth orbit altitude that exceeds circular orbital velocity by tens of kilometers per second. To transition from that hyperbolic approach velocity to 7.66 kilometers per second, the precise velocity required to co-orbit with the ISS rather than pass through low Earth orbit on a hyperbolic arc requires shedding 38.4 kilometers per second of velocity in a controlled deceleration sequence. NASA's Deep Space Network DSS-43 antenna complex in Canberra, Australia, recorded the deceleration profile. The complete velocity reduction from interplanetary approach speed to ISS co-orbital velocity occurred in under 12 minutes. the sustained deceleration loading that 12-minute profile implies, the g-force applied across the object's entire mass across that interval, exceeds the compressive yield strength of every silicate mineral, every carbonaceous chondrite matrix composition, and every volatile ice species identified in the spectroscopic catalog of cometary nuclei by multiple orders of magnitude. A loosely consolidated cometary body does not survive the structural loading that deceleration profile imposes. It does not survive it partially. It does not survive it with surface ablation. It does not survive it at all. ESA's Gaia astrometric mission independently confirmed the deceleration curve. ALMA's interferometric array in Chile cross-referenced the emission spectra across the deceleration window. 3 platforms, 3 methodologies, 1 result. The deceleration occurred, the object remains structurally intact, and no thermal exhaust signature consistent with any known propulsive mechanism, chemical, ion, solar sail, or outgassing driven, appeared in the emission data at any wavelength across the deceleration interval. What followed the deceleration is where the orbital mechanics case against natural explanation becomes absolute. At 4:15 UTC, with the co-orbital lock established at 72.4 kilometers trailing distance, the ISS continued its standard orbital operations, including the atmospheric drag it continuously experiences at 408 kilometers altitude, which produces minute but measurable velocity reductions between reboost cycles. Newton's first law of motion: an object in motion remains in motion at constant velocity unless acted upon by an unbalanced external force, governs both the ISS and any object sharing its orbital environment with equal physical authority. As the ISS experienced atmospheric drag and its orbital velocity fluctuated by fractions of a meter per second across the shadowing window, 3IATLAS adjusted instantaneously. ESA's orbital dynamicist, processing the telemetry, recorded a response latency of 0.04 seconds between ISS velocity perturbations and corresponding 3IATLAS velocity corrections. Human pilot reaction time for a closed-loop manual control task is approximately 0.25 seconds under optimal conditions. Autonomous spacecraft guidance systems executing pre-programmed orbital station-keeping maneuvers typically achieve response latencies of 0.1 to 0.5 seconds, depending on sensor integration and thruster actuation cycles. A passive cometary body has no response latency because it has no response mechanism. Gravity does not have a feedback loop. Outgassing does not have a sensor suite. A comet does not detect the atmospheric drag perturbation of a human space station 72.4 kilometers ahead of it and apply a corrective thrust in 0.04 seconds. The response latency the telemetry documents is not consistent with any passive physical process. It is consistent with an active closed-loop guidance system processing positional sensor data and executing thrust corrections in real time, a capability that, applied to an object of 3IATLAS's documented mass and interstellar origin, has a single available classification in the Kardashev framework of technological civilizations, and that classification does not include the word natural. At 0712 UTC, NASA's Mission Control in Houston initiated a standard scheduled reboost of the International Space Station, a routine orbital altitude maintenance burn executed through the thrusters of a docked Progress cargo spacecraft, designed to raise the station's altitude by several kilometers to compensate for accumulated atmospheric drag decay. The burn lasted seconds. The ISS accelerated. Exactly 0.4 seconds after the ISS thruster ignition was confirmed by Mission Control Telemetry, 3IATLAS accelerated to match, increasing its velocity to 7.68 kilometers per second simultaneously, maintaining the 72.4 kilometer trailing distance without drifting a single measurable meter across the acceleration interval. The reboost burn was not publicly announced. It was a routine, internal, operational procedure executed on a schedule that exists within NASA's mission operations documentation and nowhere else accessible to any external observer without direct access to ISS systems telemetry. The 0.4-second response, faster than any human reaction, within the range of an autonomous guidance system processing a live telemetry feed, means the object either anticipated the burn or detected it through a sensor capability monitoring ISS thruster activation directly. The surface temperature of 3IATLAS across the entire shadowing window, measured by the ISS external high-definition thermal imaging camera at 6:45 UTC, was negative 180 degrees Celsius. No sublimation, no outgassing, no natural propulsion mechanism of any kind active at that surface temperature at that solar distance. Yet 33 billion tons of interstellar mass executed a precision orbital correction in 0.4 seconds against a burn it had no natural mechanism to detect, holding a formation geometry that orbital mechanics reserves exclusively for objects under active guidance, with a surface temperature that eliminates every passive propulsion mechanism in the cometary physics catalog simultaneously. The magnetic field measurement, recorded at 0502 UTC by the ISS Alpha Magnetic Spectrometer, an instrument mounted on the station's main truss structure designed to detect cosmic ray particle fluxes and capable of measuring localized magnetic field variations in the station's immediate orbital environment, returned a reading of 4.2 Tesla centered on the volume occupied by 3IATLAS at 72.4 kilometers trailing distance. To place that figure in physical context, Earth's surface magnetic field averages approximately 25 to 65 microtesla depending on geographic location. A clinical MRI machine operating at the high end of standard diagnostic field strength generates 3 Tesla. The localized magnetic field envelope surrounding 3IATLAS during the shadowing window registered at 4.2 Tesla, stronger than a diagnostic MRI, sustained in open orbital vacuum around an object whose bulk composition the prior spectroscopic record classified as a cometary nucleus incapable of generating or sustaining any significant internal magnetic field. Cometary nuclei do not possess the iron-nickel metallic cores that generate planetary magnetic fields through dynamo action. They do not contain the circulating conducting fluid layers that sustain dipole magnetic structures across geological timescales. A 4.2 Tesla localized field envelope surrounding a cometary body in low Earth orbit is not a natural magnetic phenomenon. It is a contained electromagnetic architecture, and at 5:02 UTC, that architecture began pulsing rhythmically, with a pulse period the Green Bank Telescope in West Virginia confirmed was not random thermal emission, but a structured oscillation at a frequency consistent with active electromagnetic field modulation. At 0814 UTC, the ISS executed a standard automated laser ranging ping for the Japanese experiment module's external sensor array, a 1550 nanometer infrared LiDAR burst used for proximity distance verification of objects in the station's immediate orbital neighborhood. The surface of 3IATLAS absorbed the 1550 nanometer incident beam. It did not reflect it. It absorbed the precise wavelength, processed it, and emitted a return beam at 1515 nanometers, a shifted wavelength directed back at the ISS sensor array with a coherence and directionality that ruled out passive scattering from any known crystalline or mineral surface composition. The return signal encoded the first 73 prime numbers in sequential ultraviolet pulses. Prime number sequences do not occur in thermal emission spectra. They do not occur in reflected laser returns from mineral surfaces. They do not occur in cometary outgassing signatures or any natural electromagnetic process documented in the observational record of planetary science. A prime number sequence is a mathematical construct, the simplest possible demonstration that the transmitting system performs discrete computation, identifies and isolates non-divisible integers from a continuous number field, and encodes that identification into a structured signal. Within 12 minutes of the prime number sequence transmission completing at 8:26 UTC, NASA and the Department of Defense initiated a Level 1 National Security Directive covering all orbital assets and classified the Japanese experiment module sensor data globally. A protocol that in 68 years of continuous human space exploration has been invoked for an astronomical object exactly 0 times. The classification did not happen because the data was ambiguous. It happened because the data was unambiguous. To apply the full theoretical framework the forensic record demands, every data point documented across the March 25th shadowing window must be read as a single, coherent operational sequence rather than a collection of independent anomalies. Because when the sequence is read in full, the architecture it describes has a precise analog in the engineering logic of every advanced autonomous reconnaissance system humanity has ever designed, scaled to a capability level that the Kardashev classification framework places firmly in the domain of a Type II civilization operating at stellar energy scales. The deceleration from interplanetary approach velocity to ISS co-orbital velocity in under 12 minutes without thermal exhaust signature at any wavelength implies a propulsion mechanism that does not expel reaction mass in the conventional thermodynamic sense. Theoretical physics offers one candidate architecture consistent with a zero exhaust signature deceleration at that energy scale, a system coupling directly to the quantum vacuum energy density of local spacetime. The zero-point field that quantum field theory identifies as the irreducible energy state of every point in the universe, with an energy density that general relativity's cosmological constant suggests is non-zero, and that string theory's 11-dimensional hyperspace framework treats as a boundary condition of the membrane our observable universe occupies. A civilization that has learned to couple a propulsion system to the zero-point field does not expel exhaust. It modifies the local metric. It falls through space-time rather than pushing against it. The deceleration profile DSS-43 recorded is consistent with metric modification. It is consistent with nothing else the emission data permits. The 4.2 Tesla magnetic field envelope pulsing at structured electromagnetic frequencies is consistent with the active maintenance of a contained plasma architecture, a magnetic confinement geometry that fusion reactor engineering on Earth has pursued for decades in tokamak and stellarator configurations, and that a functioning compact fusion system aboard a 2.4-kilometer interstellar vessel would require to sustain the power output the shadowing maneuver's energy budget demands. The zero-point propulsion system and the fusion power architecture are not competing explanations. They are complementary components of a single integrated propulsion and power system that a Type II civilization, one operating at the total energy output of its parent star, builds as a minimum viable interstellar transit platform. The prime number sequence transmitted in response to the ISS LiDAR ping is the element of the forensic record that resolves the mission classification question. The trajectory, the deceleration, and the magnetic field data leave open. A reconnaissance system that has decelerated from interstellar transit velocity to co-orbital formation with the most prominent artificial structure in low Earth orbit matched that structure's velocity corrections in 0.04 seconds across a 4-hour shadowing window, and then responded to an active sensor ping with the first 73 prime numbers in structured ultraviolet pulses is not malfunctioning. It is not executing a pre-programmed fixed response. It identified the LiDAR ping as an artificial narrowband signal from a technologically active source, selected a response encoding that any mathematically capable civilization would recognize as computational intelligence, and transmitted it in a directed coherent beam back at the source. That is not automated behavior. That is assessment. The object evaluated the ISS as a technological artifact produced by an emerging civilization, determined that a mathematical response was the appropriate initial communication protocol, and transmitted accordingly. As of 11:59 UTC on March 26, 2026, the James Webb Space Telescope has recalibrated its NIRCam array toward the ISS orbital corridor. The full spectral analysis of the prime number ultraviolet transmission is expected within the projected analysis window. The alpha magnetic spectrometer is still logging the 4.2 Tesla field envelope. The DSS-43 antenna is still tracking. Something crossed 38.4 kilometers per second of velocity in 12 minutes. Held formation with a human outpost for 4 hours and answered when we pinged it. The telescopes are pointed, the data stream is live, and whatever assessed us from 72.4 kilometers behind our most advanced orbital platform has already decided what we are.